Hey everybody, welcome back to the Metal Mill 52 workshop. My name is Bill. This is my shop. We're working on an LBSC. That's the pseudonym of the author and designer of the locomotive, the TICH locomotive, which is a tiny little 040 tank engine, 3.5 inch gauge. And it's a great project, really fun. Really, when it's done, it'll be really nice because it's so tiny and it'll be easy to move around. So this week's episode, what we're going to show is making the packing gland nuts, which call for a little bit of precision because they're placed right here in the back end of the piston, and that will hold the packing material in to kind of seal around the piston rod that slides back and forth. So it's a little tricky, but they came out really well. I'll show you how I made those out of some 3/8 inch hex brass. And then making the actual pistons themselves, that was a little tricky as well, a little unique. I've never made something exactly like this before, and I was really thrilled how nicely they came out and how accurate they are. Like you could see this one here inside, how it fits inside the piston and the right hand how the piston and rod fit in the right hand cylinder assembly there. So came out really good. This will be a short episode this week, probably only about 15 minutes, where I show you how I made those various parts, but I hope it's enjoying and interesting to you. Of course, if you have questions, ask. I'll do my best to answer. If you just want to let me know that you saw it and you enjoyed it, please hit the thumbs up, subscribe if you haven't already, and hit the bell so you can see notifications. I try to post an update on the project probably every week or two, kind of depending on my workload and what all is going on. You can tell because I'm not bundled up this time. It's finally getting warm here. It's springtime in the central Gulf Coast of the U.S. where I live, so I'm not sure if that's going to mean more or less shop time, but we'll see. So I hope you have a great week. I've enjoyed it, and I hope this episode is enjoyable to you. Thanks, everybody. Bye. Okay, here I'm making the bushings for the packing glands. Got some 3/8 inch hex brass chucked up in my 5C collet chuck, and I've turned it down to 5/16 of an inch diameter here, and I'm using I did like it says in the book, except for I don't have a 5/32 inch reamer, so I used an end mill and got a very precise hole in the center. Very happy about that, and just doing it all in this orientation. So I'll use the tailstock die holder and thread it. I'll put a little undercut in there with the cutoff tool, and I'll show you those steps, but this is a little simple thing. So there's two of these that are a little bit shorter that are for the packing glands for the pistons, and then there's two that are longer that'll go into the steam chest up top here. So while I've got the material set up and all the tools out, I'll go ahead and make the longer ones as well. Here we are center drilling. Even though there was already a hole there, always a good idea to center drill for the area that you're going to be drilling for. Here we are drilling out with the number 23. It's just undersized for 5/32, so the end mill doesn't have to remove much, but it was interesting using the end mill a minute ago on the first one. Really had to back it off every few thou, or every 50 thou or so. I'll show you that in a minute after we get this drilled through. And this one's doing it with the sound on again, but you can see the 5/32 inch end mill, which I used to make the perfect 5/32 inch hole there, which would be excellent for the stainless steel piston rod itself, rather than using a drill, which could give you an oblong shaped hole. And here we are using the tailstock die holder to do the 5/32 by 32, 5/16 by 32 threads per inch thread on it. I started making the thread before I remembered my little undercut here. It's a good best practice to do a little undercut before you're going to do threads on something. So just going in a little ways, probably about 10 or 15 thou total. Okay, once the threading is done, it's a simple matter of cutting it off an 1/8 inch from the shoulder there. One thing I always like to do is use slow speed with the cutoff tool plenty of lubricant and back it off a little bit and file the little valley there. Triangular file comes in really handy for this. Soften both the part you're making and the other part, so it'll be ready for the next part you want to make. That should do it. And the only other trick to it is when you get close, I like to stick a wire in there to catch the part, so I don't have to go digging around the bottom of the lathe to find the fastener we just made. Alrighty, here's the finished product. Pretty happy with how it came out. The other one is identical. Where is it? There it is. And here, see if I can do this one-handed. I've got a piece of 5/32 inch stainless steel rod that will be the piston rod and the valve rods, and you can see it fits on there nice and smooth. There's no shake, so it's going to do just fine for our purposes. And let's do a test fit in here. There we go. Nice, nice, nice. I'm very happy with the fit for both of those. So tonight, while I'm out here, I'll go ahead and knock out a couple more of these things, a little bit longer, for the steam chests. They'll go in whenever these get machined. They'll go in there to seal off the piston rod area. Alright, the first step in making the pistons is to cut the 5/32 inch stainless steel rod to the correct dimension. So I've cut two pieces that size. I've got one in the 3-jaw chuck. I don't have a 5/32 inch 5C collet, which I did. That would make life a lot simpler for a couple of things. So I'm using the 3-jaw, and I'll use the tailstock die holder to put a just an 1/8 inch long piece of threading on here that's 5/32 by 40. So that comes next for both of these. Okay, got the first one threaded, and it was quite a chore. I wasn't able to just simply use my tailstock die holder for the threading portion. I had to actually cut the threads a little bit on the lathe first, and then chase them to clean them up with the die holder. So far so good. Okay, gonna get ready to make the pistons, and I wish I could find a way to use these little chunks of cast bronze that came with the kit, but honestly they're just so short and so tiny, there's really no good way of making them, they're grasping them in the 3-jaw. It's just there's not a lot of material there, and I don't want to waste half a day or a day or two trying to figure out a way to machine these things and then, find out that it's not going to work. So in the interest of time and getting it done, I decided to use this big chunk of bronze I had left over. It's actually the same piece that I used to make the bearings for the brake shaft. I cut that down, but it's about a little over 1 inch in diameter and a couple of inches long. So what I've done, I'm going to try to follow along the procedure that they talk about in the book, leaving about 1 inch and 1/8 sticking out here, turning it down to just like 30 thou over the diameter of the pistons, and I'll drill it out like it says, and drill and tap portions of it, cut it off, put the grooves in there like it calls for. So I'll show you step by step as we go, but decided to do it that way in the interest of time. Okay, so now I've turned it down to 732.5 thousandths. So I precisely 1/32 of an inch greater than the inside diameter of the cylinders. So now I can go ahead and do the work on the centers and create the grooves and so forth for it. But that'll be enough material left that I can chuck it on the piston rod and turn it down to the final diameter. Okay, I had to swap out. I used my Mac Daddy cutoff tool, which makes an excellent grooving tool, to put the graphite packing slot in the piston blank. This is a 3/16 inch drill, and you can see it just fits just perfectly, and it's a little bit, like as I showed before, the blank is 30 thousandths thicker than the finished product, So I've already drilled the center hole with the number 30 drill, so now it's just a matter of cutting this off and repeating and making the second blank. Here we are cutting off the first piston blank. Cut it down to 70 RPM so I don't mess anything up, taking really tiny little cuts. I have this piece of steel, as you can see, in the tailstock drill holder, just to catch the part when it finally cuts loose there. Taking it nice and easy. It's going pretty well. I don't want to mess this up, so take our time and do it right. Alright, here's the two blanks cut off. You can see the little cut off area there. I've got this one in to clean it up. I just finished facing it off and getting ready to drill and tap it. Okay, after facing off, I opened up the hole. Piston rods into the end of the piston. And the last step for assembling the pistons is screwing the piston rod into the piston itself. And I just finished this one. Let's see, let me pull that around like that. That actually worked out pretty good. And here's the one I did before. See, it came through just a little bit, but pretty happy with how these came out. I did cheat a little bit. Like I said, I used my 5/32 end mill to create the hole up until the tapping spot, so the last 1/8 inch or so. Because the stainless steel of my piston rods, it's
it's hard to explain. It measures out exactly at 5/32, but as you can see, it's kind of coated with something like some Parkerized type coating, and it was a devil to machine, so I didn't think it would slip inside the bronze very easily. That's why I went ahead and opened the holes up a little bit, but I think it's going to be good. Alright, I'm cleaning up the outside of the piston. Should be one more pass to get it to fit, so we'll see how that goes. Okay, as the saying goes, I'd rather be lucky than good. This is just about the perfect sliding fit, maybe just a wee bit on the snug side, maybe a half a thou too much. I need to deburr it anyway because you can see the cutter raised a little rim on all the edges. So I'm just going to touch this lightly with a file, and I think we'll call it good. I'll point this out. I did clean up the end on the lathe first, and this stainless steel is so tough I ended up actually using a grinder, using a Dremel grinder just to grind that flush.
Alright, this is a productive little hour at the lathe. I got both of the pistons turned to their final diameter, and as you can see, the fit is really nice. Very smooth, no shake, and really it's the rewarding part is to know that your careful work on all of these parts, ensuring that the hole is in the center and it works and the piston can slide up and down without any binding. It all comes together and it's a rewarding feeling. So this is the first one I did, and you can see a couple of little accidental grind marks there where I was grinding the stainless steel center down. I thought about silver soldering these on, but I couldn't untwist them by hand even when the shaft was held in the lathe in that clamping device, so I decided not to do anything else and just leave it like it is. So I think they'll be fine. And you can see I did mark, I don't know if you can see that, the left little L here on the cylinder, and one on the cylinder cover there as well. Here's the right side. I just finished, that was the second one I did. Again, nice smooth fit and no shake, and it came out really good. I'm really excited, really happy about that. So the center portion there, it looks like it's cut out for an O-ring, but that'll actually be filled up with graphited yarn packing. I've got plenty of that stuff that I'll use. And the back of the piston rods, they'll get a hole drilled that will connect them to the connecting rods. So that comes much later in the process. So for now, excuse me, let me put this back together, show you how nicely it goes in there, slips in, really good, really happy about that. I think I'll just put the front covers on so they don't lose them and they don't lose the screws. And the next thing I'll focus on will be the steam chests, and then of course the slide valves. The set I bought used already came with machine slide valves, and they look like they're done properly, so I'll plan on using them. If that doesn't work out for whatever reason, I do have a set of the valve castings that I could use. And then I did buy some cast bronze covers, steam chest covers. And one more thing while I'm yapping here, it's interesting. The steam will come in through ports on the side here, from the boiler down through a T, and the steam pressure pushes, since it comes in here, it presses down on the valve to keep it flush on the face here, and then the valve rod moves it back and forth. You can look at the video where Fred set the timing on my Allen Mogul over there, and you'll see a larger size version of the very same thing. So pretty neat, pretty interesting, and quite a lot of fun. Thanks again, everybody. I'll keep you posted as we move along.